So this is lecture number 3 of functions. Let's just start. We have already done composite and we have done the inverse. Today we are just working on the graphs of fx and f inverse of x, and then we will move forwards toward the composite domain and composite range. So let's work upon if the question says draw fx and f inverse of x. First thing first, the relationship of fx and f inverse of x is reflection underlying y is equal to x. It is relationship of fx and f inverse of x under the line y is equal to x. That means coordinates are interchanged. Now, with this respect, if the question says that we have fx as 2x plus 3, or let's say 2x plus 1, and we have been given points, or we'll draw the curve. The graph might be given or you need to draw yourself. So let's just draw the graph. So if we say that we have x-axis and y-axis. This is your x-axis, this becomes your y-axis. On x-axis, you have points 1, 2, 3, 4, 5, 6. So you will have -1, -2, -3, -4, -5, -6. Similarly, on y-axis, you'll have 1, 2, 3, 4, 5, 6. -1, -2, -3, -4, -5, -6. Now, normally, the graph is represented through x as element of all the real number. That means we can take any numbers for x. So that means if we take 0 in x, so the answer for 0 will be noted as what? 1. If we take 1, the answer would be 3. If we take 2, the answer would be 5. If we take -1, so this will be -2, -2 plus 1 will become -1, somewhere here. So there would be a straight line graph that will be drawn for what? Fx. Now this is representing fx line. This is representing fx line. Then you need to understand, since it is reflection, so 1, 1, 2, 2, 3, 3, 4, 4. So this line becomes the reflection line of y is equal to x. Reflection line of y is equal to x. So this is y is equal to x. Then what do we have? We have, if this is 0 and 1, so the coordinate 0 and 1 will be reflected to 1 and 0, because 0 and 1 will be 1 and 0. So the point will come here. 1 and 3 will become 3 and 1. 1, 2 and 5 will become 5 and 2. So that means if we just draw the graph would be 1, 0, 1 will be 1, 0, right? Then we have 1 and 3. I'll just correct this thing down. 1 and 3 will be 3 and 1. Then 2 and 5 will be 5 and 2. So similarly, the graph of f inverse of x is moved in this direction. So that becomes f inverse of x. So that means for f inverse of x, the coordinates will interchange and this will be represented at what? Your f inverse graph. So always remember, for fx, for any x is element of all the real numbers, you can take any values respect to 0, 1, -1, 2, 3, and then you have got the coordinates. You can always interchange the coordinates to have your answer. Now, let's work upon composite thing again. Composite, range of composite, majorly. So let's just write down composite function. What is composite? That we already know. That means always substituting the value. Let's say that fx is equal to 2x minus 3 and gx is equal to 5 minus 2x. And the question says we need to have f gx. So for fgx, we need to substitute the gx function in what? Fx. So this is 5 minus 2x minus 3. 5 minus 2x minus 3, 5 to the 10, minus 4x minus 3. So that means your answer will be 7 minus 4x. So this is representation for fgx. Similarly, the question would have also be asked for gfx. So that means we need to substitute fx in the function of what? Gx, 5 minus 2, x is 2x minus 3. So this is supposed to be 5 minus 4x plus 6. So the answer is 11 minus 4x. Now, when does the, if the question asks composite function existence, composite function exists. So if fgx exists, it will be when the range of gx falls in the domain of fx. Then fgx exists. We can always equate the domain of fx to the function of gx. On the other hand, if you want to understand that gfx exists or not, same thing, gfx exists. So what we're gonna do is we will be looking forward when the range of fx falls in the domain of gx. So let's just write when the range of fx falls in the domain of gx. then g of x exists. Or we can always equate domain of gx to the function of fx. Function of fx. We'll be doing more questions about this when we'll be clearing down the past paper questions, but normally when the FGS exists, so it only exists when the range of gx falls in the domain of fx, then fgx exists. So that in that way, equate the domain of fx to the function of gx. So you will be getting the answer for that. Similarly, gfx exists when the range of fx falls in the domain of gx. Similarly, equate the domain of gx to the function of fx. But now, most importantly, what you need to understand is range of composite function. Range of composite function is important. For range of composite function, so let's say range of fgx, that means gx is substituted in fx. So there are steps that needs to be followed. Step number 1, find the range of gx using its domain. Find the range of gx using domain. Once you substitute the domain of gx in gx function, you will get the range of gx. Then, step 2, use the range of gx as the new domain. Use the range of gx as new domain of fx, as a new domain of fx, and now equate the range of fx under its new domain, which means when we use the range of gx as a new domain of fx, and then the new domain of fx is substituted in fx, you get what? The range of fx. So that range, let's say this is your step 3. The new range of fx is basically the range of fgx, is the range of fgx. So let's just do it with a little bit of normal puzzle thing, that we have fx, we have gx, and we are finding out fgx, right? We're finding out range of fgx. So if we need to find out range of xgx, your gx function will have domain. Find its range. This range of gx is basically your new domain of fx. Then use this fx domain to find what? Range. This range, particularly fx range, using the range of gx, is basically range of fgx, is the range of fgx. Now let's do this as an example. Let's say that my fx is 2x minus 3 and the domain of fx is x greater than equal to minus 1 less than equal to 3, and gx is 5 minus 2x. So the domain of gx is minus 3 less than equal to 5. And the question says range of fgx, range of fgx. So what we're gonna do is use gx first, because this will be used for what? This will be used for the range of fgx. So we will be using what? Gx first. We'll be finding the range of gx through the domain. So we have two values. We have minus 3 and we have 5. So gx is 5 minus 2x and domain is minus 3. So g minus 3 is 5 minus 2 minus 3. We get 11. G5 will be 5 minus 2, 5. So this should be minus 5. So gx is greater than equal to minus 5 and less than equal to what? 11. So this becomes the range of gx. This was your domain. Now this becomes the range of gx. This range of gx is basically new domain of fx. So now we'll write this thing as x greater than equal to minus 5 less than equal to 11. And the fx function was 2x minus 3. So if we just use this f minus 5, so 2 minus 5 minus 3, so we get what? Minus 13. F11, so this is 2, 11 minus 3, we get what? 19. So your fx, the range of fx is basically minus 13 less than equal to 9. So using the new domain, which was the range of gx, using it as new domain of fx, we found the range of fx. This range of fx is basically fgx range, which is greater than equal to minus 13 and less than equal to 19. So this is composite function range of fgx. Okay, so let's just work upon range of gfx now. So range of gfx. So for range of gfx, your step 1, find the range of fx using its domain. Now, since you have the range of fx, range of fx is new domain for gx. Range of fx is the new domain of gx. So evaluate the range of gx under new domain. So step 3, the new range of gx is basically the range of gfx, the range of gfx. So considering the same question as we did, we made sure that we do fx is equal to 2x minus 3. This was the question. Fx is equal to 2x minus 3. Domain was x greater than equal to minus 1 less than equal to 3. So since we need to find gfx, we need to substitute the domain of fx in fx. So let's just do this. So can we just, for range of gfx, your fx was 2x minus 3. And the domain was itself given, which was minus 1 and 3, right? So f minus 1, 2 minus 1 minus 3 becomes minus 5. And f3 will be 2, 3 minus 3, which means this is 3. So the range of fx is minus 5 less than equal to 3. So this range becomes the new domain of gx. So gx is 5 minus 2x, 5 minus 2x, and the domain of the gx will be minus 5 less than equal to 3. So let's say substitute g minus 5, 5 minus 2 minus 5, the answer is 15, and g 3. The answer will be 5 minus 2, 3, 6, which means 1. So gx range is 1 minus 1 and less than equal to 15. So gfx will be same as gx minus 1 less than equal to 15. So this is the composite function range. And obviously, if you really want to find the domain, so the domain of fgx will be the range of what? Gx. Similarly, the domain of gfx will be the range of what? It will be the range of fx.